This demo here is a demo involving superconductors and quantum levitation. What we've got here on the table right now is a little disk of BSCCO, which is a superconductor. That stands for bismuth, strontium, calcium, copper oxide. Bismuth, strontium, calcium, copper oxide. And this is a tiny little magnet in the shape of a cube. And before we start this demo, what I wanted to show is that right off the bat, this is not floating, because while the little cube is a magnet, this disk, this superconductor, is not a magnet. So it doesn't float, it doesn't stick to it, it's just there. But superconductors are materials that when you cool them down to a low enough temperature, the resistance inside of them decreases to almost nothing. When you do that, all sorts of weird stuff can happen. For BSCCO, we have a critical temperature, a temperature where it starts to behave like a superconductor that's around 110 Kelvin. Our classroom is much warmer than 110 Kelvin. So what I'm going to do is I'm going to dump some liquid nitrogen on top of this. Liquid nitrogen has a temperature of about 77 Kelvin. So when we pour it on, it will cool our disk down until it's a lower temperature than its critical temperature. So it will start superconducting. And we're going to start to see some quantum levitation happening. At this point, it's hopefully cold enough. I accidentally knocked the magnet off. Not quite. We have to get colder. Oh, there we go. And what we can start to see is our magnet is actually floating above the superconductor. What's happening is normally with this magnet, it's creating a magnetic field all around it, and that magnetic field is going through our superconductor. When it's above that temperature, that's fine. It's not a magnet, so it doesn't attract or repel. But at this point, when it gets so cold that it's lower than the critical temperature and it's superconducting, the resistance inside is so small that the magnet, we can cool this down a little bit further, the magnet, as it pushes and pulls on the electrons in the superconductor, actually causes them to move in circles. It causes a little tiny current, what we call an eddy current. And so the magnetic field is causing electrons in our superconductor to move, and there's so little resistance that they can move freely. And so as they start to move, they actually create a magnetic field. That's what creates magnetic fields, is moving electrons. So when our magnet is up here, it's creating a magnetic field in the superconductor that is just slightly lower, or not just slightly lower. The magnetic field that it's creating is perfectly opposite of the magnetic field of the magnet, and because they're opposites, it starts to repel. And so when we keep it cold enough and it's still superconducting, it's creating that eddy current that is creating a repulsive effect that's strong enough that it counteracts the gravity. Gravity pulls the magnet down, the magnetic field is repelling, and so it pushes the magnet back up, and it floats. And you can give it a nudge and make it spin, but because whenever it's moving, even though when you spin the magnet like that, the magnetic field is changing, it's changing those eddy currents so that it's always being opposed. It's always creating a perfectly opposite effect.